Hello, everyone. Welcome to this event marking the International Asteroid Day. My name is Etimofiong. Thank you for joining us. And we are expecting more people to join. I know it's Monday morning, especially in Africa. So some people may be at work or on their way to work or maybe school. So we see who people will join us. But of course, we are recording it, so those who can't join can actually watch later. But it's a very interactive event, and I'm really looking forward for us to interact. So whether using the chat box or maybe raising our hands at any point in time. So let's make it interactive and educative, informative, and try and get the best from it. Um, well, I know me before coming, you've probably tried to read up about International Asteroid Day, what's it about, and what's really the background behind it. So I won't try to go deep into that, but just to say that I think 30th of June 1908, an asteroid called Tunguska landed in Siberia, which is around Russia. And it's said that that's the largest recorded asteroid impact on the Earth. And so the UNUSA or COPUS decided to use the opportunity to raise awareness about the threats of asteroids and near-Earth objects. We'll get to know about near-Earth objects very soon. So 30th of June every year was chosen as the International Asteroid Day. The other interesting thing is that in 2029, it's also projected that sometime in April, a particular asteroid, well, I don't know how they call it, but it's 99942 Apophis. So I don't know if that's the correct way of pronouncing it. But that asteroid will pass kind of close to the Earth, but it won't hit the Earth and it won't pose much threat to the Earth. So the UN also has declared that year 2029 as the International Year of Asteroid Awareness and Planetary Defence, also to also raise awareness about asteroids, their scientific and resource value, and their potential hazards. Um, some people know about the hazards from asteroids, but some people are not aware about the potential minerals, rare earths, metals, or that we can also get from asteroids too. So it's like there are pros and cons, so to say. So what we decided to do at ASLI is to kind of organize this roundtable and try and discuss this topic from an holistic point of view. As you saw in the announcement, the theme is Planetary Defence, Africa's role in global preparedness. And we hope to dig deep into that topic and try and cover all the aspects of that topic. And that's why if you look at the speakers have different backgrounds to speak to the science, to the engineering, to the business, and also to the policy and legal aspects of the topic. But to set the stage, we'll start with maybe a short presentation about asteroids and near-Earth objects so that we are all on the same page about what we are talking about, especially because some of us may not have a space science background. So Dr. Youssef Moulane will give us a short presentation before we now go into the main roundtable discussion. Uh, just as a way of introducing him, Dr. Youssef Moulane is a research scientist in astronomy and astrophysics at the University of Applied Physics. That's in UM6P in Morocco. He previously worked as a postdoc at Auburn University in the US. His research focuses on the study of the physical and chemical properties of small bodies of the solar system, including comets and asteroids. He is also interested in studying the cosmic microwave background and the origin of the universe. He holds a Ph.D. in astronomy and space science from Cadi Ayyad University in Morocco and the University of Liège in Belgium. I need to also add that Dr. Moulane is one of our facilitators at ASLI, always taking the course on the outer space environment, where you have a complete, usually I think about 5-hour lecture, so we have to split it into two. of a 5-hour lecture on asteroids and every other thing about space science. So thank you, Dr. Moulane. You have the floor, please.
Thank you very much, Etim, for this presentation and for inviting us today for this event, which is the International Asteroid Day. So, and I'm happy that Africans start to get awareness about this, because this is, as we called it, it's a global challenge. So this is stated by the International Astronomical Union. So say this day, 30 June, as the International Asteroid Day. And the basic idea behind it is to spread the awareness about how this the challenges of the having asteroid maybe getting impact with Earth, and we should make this awareness not just to let people know, but also to prepare and to develop some strategies that we can maybe mitigate this risk that might be really danger for our planets, which is we are starting or we're already protected from many things like climate change and many other global challenges. And this asteroids or the small bodies of the solar system are one of the risks that they might be threats our existence or our life on the planet. This is why we are very interested to talk about this and share this awareness, and also try to prepare from our side as Africans, from by observing, by participating in research, by education and participation through education and outreach, as in many aspects try to help in this global challenge and be ready to challenge this this risk that they are coming outside from our planets. So as Etim mentioned, so I will go for a short presentation, giving some background about asteroids, what they are, where they're coming from. I will not go too long, because the main idea here is to have a discussion and answering questions from the audience and also from the moderator, to try to not to lecture, because this is our way to work sometimes, but sometimes we need to change a bit. And then at the end of this roundtable discussion, we will finish with like call it a funny animation or a simulation about what the damage that can asteroid make. So for example, based on their size and so on. This is something maybe I will encourage you to stay at the end, and you can enjoy it a little bit. So so far. So I'm assuming that all you know our solar system. So you know that we have planets, and our lovely one is here, our planets, and we have the Earth, and then we have the Moon, we have other planets. We have the 4 planets closer to the sun. We call them terrestrial planets, like they are like our Earth. And then between we have asteroids, which we call the asteroid belt, and then we have the gas giant planet like Jupiter and Saturn. And then we have what we call the ice planet, like Uranus and Neptune. And then we have many other things behind them, including the Kuiper belt, which is mainly composed of comets. I will explain later what is the difference between comets and asteroids, and which one can make a difference in impacting the Earth. So today we will be, since we're talking about asteroids, we will be talking about this place. But the problem is asteroid, if you think that they exist only in this place, this is not right. So because there are many exist in the place, but there are many others randomly exist within our solar system, and especially close to us. And this is what we call them near Earth objects for our colleagues from French people. So we call them les objets du croiseur. That means a near Earth object that the orbit of this object, of this asteroid, it cross somehow the orbit of our planet. And that they might make some potential risk on impacting our planet. And this is why we're interested as a scientist today in first finding this asteroid. And I think you see lastly with the press release with the Auburn Observatory, LSST, who find the first shot like more than 1,000 asteroids. And this is one of the objective of this telescope, which is the 8-meter telescope located in Chile, is just to find more and more asteroids, especially in this region, which we call it near Earth objects, and then trying to track them. And then if we think that some of them they're gonna hit us, we should find ways how we can deviate them from their orbits. So yeah, it's not simple as you see here. By the way, the image here is not to scale in terms of distance. So many things are very far away from each other. But if we want to log the existence of asteroids or their orbit, this is how they look like. So they are everywhere. This is the orbit of the planet, this is the sun, and this is the orbit of the asteroid that we call them the near-Earth objects, or in French, the géoquasars. So we are very interested knowing the position of any of this, let's call them enemies, or somehow you can go to whatever you want. So it's just some object that making threats to our planet, and we have to deal with them. So just to show you the simple, now like make a zoom within the Mars region. So the Earth region, the Earth is here, you see that how many asteroids that they are crossing the orbit of our planet. And you know, space is big, very big. Don't think that this thing is small and that maybe some asteroid is coming to us now, or the probability is very high to get a risk. No. So space is very big. So when you see this, like just like a trajectory of this asteroid, that means that the probability of the interaction of the impact of asteroid with Earth is very slow, is very low. So here I will show you some data. So what we're seeing here is kind of simulation of the orbits. You can do that because we know the opposition. Now we wanted to see the observation or the data. So you know, this is the date, the year, and here you have some number, which is the discovered asteroid every year. And you will see this is increasing. And of course, you will see it's increasing rapidly later because now we have more technology and more telescopes located different places around the world just to observe and find this asteroid. And you might ask this question, why we cannot find them at once? Why we should spend a lot of time, years and years to find this billions of asteroids? Why we should not like just point our telescope? No, so the telescope, this object, first, they are located on different places. They're not observable at the time. And second, they are moving. They're not like the stars, you see them like they're not moving. They are moving all the time. And thirdly, they have different sizes. So you cannot, so the reflection of the sun depends on their sizes. They are one of the small, they are one big. The big ones we have already discovered like a long time ago. But the problem is the smaller one. And what I mean by smaller ones is this one within a size between 30 to 100 meters. And this is not small for us, so it's still big if it hits the Earth. This is the problem. So what you see here in the green are the objects located within what we call the asteroid belt, which we call it, let's say, a safe zone. This is why it's in green, and I have just shown it now. But you see there is a lot of other objects with different colors, except for this one, the blue one are the planets, the yellow one is the sun. But you see different colors, or one, you see the orange and you see the red one. This one, the near Earth object, or the géoquasar. So you see this object are located within the existence of our planet. Our planet is just here. And when you see it in white, it's the spot of the number of the asteroids have been discovered every year. And as you see, within the last few years, last decades, let's say, we have discovered more and more because we have some telescope dedicated only to that. The simulation will stop here within 2015 or 16, like 10 years ago, within 600,000 asteroids. Now there are like, we have the estimation of that we got more than 1 million. And we believe that there are billions of this asteroid, billions of the small rocks exist within the solar system. But the first target for knowing this asteroid is this guys within this red color here, which is they are making some threat to our planet. So we have to find this object here within our planet, and we have to track them and try to simulate their orbit and see if they might have some probability to hit the Earth, and we should behave into protecting our planet. We are smart, we are humans, so we should find a way how we can, we believe in ourselves, we should find a way how we can deviate this object before hitting our planet. And this is, people talk about the climate change. Okay, if we just increase it by 0.5 degrees, so people will be in like, you know, danger and whatever, and life will be existing. We're talking about it. But also, if we get hit only by one asteroid, and depends on the size, hopefully will not be small or big. So we can also talk about the extension of life. So if it hits first, we don't know when it's gonna be hitting. The same problem with the climate change, and the problem is when it hits anywhere, it will make damages. If it meets like some urban places, it will damage cities and probably some large infrastructure. If it hits the sea, it will create tsunami and would create also some dramatic events and so on. So that's the problem with this object. So we will go through that later by when we do the simulation at the end and after the discussion and so on. So the object, not all asteroids they are our enemies. There are some asteroids, we call them, they are good for a reason because we can go and explore them, and this is what NASA and JAXA did recently. So we can use asteroid as a resource for our planet. We can bring a lot of materials from them, and we have already started that, and this is what we call the mining in space, or space mining. But this is our one you see in the green or in the safe zone, so we don't have any problem with them. So basically, but we have a problem with this, what we call the near Earth object. This is could be a comet or asteroid that they have their orbit passing the orbit of the Earth, and their size is ranging between few meters to a few hundred of meters, and this is why we believe that within our Earth, like, or what you call the Earth object, so they are between this 45 million kilometers of the Earth orbit. This is what we call the near Earth object, and they have some probability to hit the Earth. And our duty today is to find them and track them and try to find a way how we can evade them. And this is why the International Astronomy Union, sit today to remind people about this objective every year, that there is some work we have to do toward this problematic. Well, if you first time you're seeing an asteroid, this is how they look like. So they are small, they are big, they are different shapes, especially irregular shape because they are small, and this is because not have enough gravity to make a spherical shape, like, for example, the case for Ceres, which is one of the largest asteroids in our solar system, which is have like 1 kilometer in diameter, which is like spherical shape, called dwarf planet also. But all the smaller ones, the Ceres, we call them like they have the regular shape because you don't have that enough gravity to make them spherical. And this is what you see. Also, they have a lot of craters on their surfaces, and this is very crazy because this is their impact with other smaller ones. So there is no asteroid we have found until now has no craters. There is no asteroid with a smooth surface we have found so far. Means the interaction or the collision between these objects within our solar system is frequent. It exists. I mean, given the timeline that asteroid have been existed, which is 4.6 billion years, which is the time, the lifetime of our solar system, of our planet. And we basically, I did my PhD on this topic between asteroids and comets, and I was studying their other benefit because we can use these objects because we call them the leftover of the solar system, because they are after the solar system formation, after the formation of the planets, they were left over because they could not make a planet, and we can now go and track them and try to study them and use them as a leftover from that age to understand what's happened to the formation of our solar system. And this is really good for comets, because comets exist in a very far away distance from the sun. So it means that the material or the information have been frozen for like years and years as ice, and then when it comes to the sun, it sublimates, and then we can start studying that. And the same for asteroids. So you also have kept some information that we can study later on. And by the way, in this picture, you don't see only asteroid, but you see also some pictures of comets, like this one, Borrelli, like all this one are comets here, and the other ones here are asteroids. And you will see this comet, they have some activities because they have some ice, not asteroid. So it seemed just talking about one of this first candidates. Well, not the first candidate, but one of the candidates that's going to hit our planet, which is Apophis 99942, which is a near-Earth object. And we expecting that it's going to pass April 2029, April 13, 2029, within like a very few kilometers from our planets. As a probability of hitting the Earth 2.7. We are talking about an asteroid with a size of 405 meters in diameter, like almost like a Tour Eiffel or something like that. So this giant object called Apophis is going to come closer to us in like 4 years from now. So what we are doing to that. So this is why we are bringing awareness. This is not only one. There are many others, and there may be some others. The problem is that we might got some others that we don't know yet. For example, this one, we know where it is. We can track it every day. Every single moment we can enter and do simulation, and we know where it exactly is. But the problem with this, we did not discover it yet. And imagine is just they're gonna surprise us and they hit the Earth and somewhere, and they will give it some catastrophic event. And this one, the NASA and ESA, they're already preparing some business about this. It just, when it passing closer to us, we're gonna track it with the spacecraft and try to study it in close because it's coming to us. But we are safe. It's 2.7 now. I think it's getting down to 1.5% or something like that. So does mean that there is no big risk for having this asteroid hitting the planet, but does not really exclude other possibilities that may exist already, and we're still not aware of it. So I want just not to spend more time just talking about that, because I know they used to give this lecture about asteroid in like 1 hour, but I will just keep it short for discussion because this information we can look at the major, but maybe you have my other question. So there are a lot of potential risks posed by this asteroid. So first, the impact event. So when they collide with the Earth, and we will show you some examples that they have done before. They also, if they hit the ground, they will make really great impact and extinction of many other things on the Earth. If they hit the ocean, they will make some shock waves and tsunamis, and also this is also can contribute to some consequence that it might be very difficult for some areas. And also it contributes to the atmospheric effect. So when they evaporate in space, this will affect also the climate, but not at the same order as the other things, but it will somehow increase the temperature and disruption of the weather patterns somehow. Many events happen on the same area for many times. So if you want to see, this is one of the big craters in the United States that's created by impacts, and you can see visiting now. If you one day want to the Arizona, I have them there. It's just like very huge craters here. So and this has happened like long time ago. We have something like in 10 years ago within in Russia, which is like 20-meter asteroid, and it hits the area. So you see this has also again happened in Russia in 1918, and there are many craters exist show that the collision of this object with Earth exists, and we have seen that in the past. And there is no guarantee this is not going to be repeated in the future. So, and we don't know where it's going to hit. That's the problem. The next impact, we don't know where it's going to be. Tokyo, in Kenya, or whatever, in Morocco, in Egypt, in Chicago. We don't know when it's going to be hitting. So, and this is why we call this, it's a global challenge, like the climate change, because when the climate change increased by 1 degree or 0.5 degrees, it's a problem for everybody on the planet, not only for Americans or for Europeans, it's also for Africans. And the same also for this impact. So nobody's guaranteed where it's going to be impacting. So because this object have random orbits, and Earth is rotating, is not facing only one side to the space, it's rotating 24 hours. So every 24 hours. So the problem is it can expect that. So, and that's why this potential damage is maybe called very risk for like flooding or injury or death or many other catastrophic events that we will like to see on our lovely planet. And this is why we have to develop plans to search first to find this object. And this is what we call the strategy of planetary defense, developed basically by NASA and ESA and other agencies. And we have to be on board with them. This is the message now to the African Space Agency, which is just settled. So we have really to be involved within other space agencies to work on this topic, because it's also concerning us. First, we have to develop our infrastructure. We have to contribute to education and outreach, and we have to be at the level, because also we are maybe target of this. So there is a plan, and this plan is based on different pillars. Maybe we can discuss them during the discussion. So first, we have, if we want to find a solution to divide this small bodies of the solar system, but basically asteroids. First, we have to find them, search and find them. Second, we have to characterize them. We have to know what they are made of. So we can study them through telescopes like infrared and visible telescopes. And this is what we are doing here, at least in Morocco and in other places. So trying to find the rotation period, what their chemical element, what they are made of. If we want to react to them, we can know what kind of enemy that we are looking at. And even in the war, you say that you have to really characterize your enemy if you want to like you really got it. So you have to locate it and characterize it, like study it. And the same for asteroids. We have to study them to know what they are made of in order to really have a proper way to deal with them. Then most importantly, we have to plan and coordinate, because this is not only a problem of a country or of a region or of a continent, it's a global problem. We have to coordinate between all the efforts, all the global effort to be made to try to, like, in terms of planet sending missions or studying them or whatever we want to do, we have to do it globally, really, to have all the hands on the same place to get this done. And then we have to think about the mitigation. So what's technology that we can use or techniques to try to divert or to disrupt this asteroid in space before coming to the Earth. Because when they are coming or on their way to the planet hitting, there is no way to deal with that, because this will like happen in a few seconds. But we have to deal with that when they are already in space. And this is easy. I will explain it like in this way. So imagine that we have an asteroid that we have identified based on the simulation that is from now to 100 years in future. It will have probability like 50 or 60 or 80% to impact with Earth. We can do that now through the simulation with our computers. We know where we use the physics of Kepler laws, and we know where this object is going to be in like 1,000 years from now. We know where exactly. And of course, we know the movement of our planets in our solar system. We basically control the movement of all the objects in our solar system. That's we know so far, the object that we know. And imagine that we find an object that from 100 years from now, it's going to impact or have a risk of impacting with Earth. So the idea is to try to act now. Means that we can go and deviate this object from its orbit by a little bit from its orbit, and will automatically change its orbit forever and will never hit the Earth 100 years from now. That's the basic idea that we can maybe work with. And there are many other ideas to do, to work with so far. So if we want how to involve the African community on that, so we have to help on this locate and find this object. And this is we can do even through small telescopes. We don't need big telescopes to do that. We have to coordinate between ourselves, amongst us now, and especially through the space agency, African Space Agency, and other national space agency and observatories around African continent to make some global effort. And then we can coordinate with our colleagues with the United States or Europeans or Asians and so on. And we also have to develop some techniques or technologies about how can we redirect this object. So yeah, there's many other ways. Maybe we can discuss them. There are some people proposing the crazy ideas like through the gravity or impactor or like even a nuclear bomb, whatever you can, a way to think about it. But let's try to find a low cost one and smart one to do that. And one of the tests that has been done by the United States recently and other agencies is the DART mission. You may have heard about that. It's a test of deviating an asteroid around its moon. I will not like take more time to talk about that because we're in a hurry, but maybe we can back to it later. And the idea is just to go and deviate the moon around its main asteroid, because also within our asteroid population, we have many asteroids in a double form, like two asteroids around each other, and this exists a lot. We have find them in our solar system, and the idea do the test within with the asteroid with the Earth. It's a bit risky, and we cannot test it because we cannot measure it. But we can do the test on something that we can measure, which is like a binary. We call it a binary system, like this one with the these two asteroids, and it happens and it succeeds. And here you can see on the left side that the big one, the big asteroid on the left, and the asteroid that is going to be impacted by a DART mission, and they succeed to do that, and they succeed. And here we can observe it within. We can see the effect of the collision between this impact and the smaller one here. And you can see this ejecta. And they really succeed to change its orbit by like a half an hour, like 30 minutes, something like that. And that's so really amazing. We are the first time testing that, and it works. So it means that we can do that, and we can apply to another asteroid that it might be hurt the Earth from now to like 1,000 years or like 100 years. We can protect our, especially for this we already know, and this is really amazing. And now we have to really, maybe we can develop this technique or other ones to try to protect our planet from this object. So I will not like take more time so on just lecturing, but we would like to have discussion with other colleagues. So there's a lot to do, so but let's discuss about that, and especially for Africans, how we can help that. And yeah, I'm done. So Itim, now it's to you.
Oh, thanks a lot, Dr. Moulane. That's a very interesting lecture. Even though brief, and like I said, I mean, we can use 5, 6 hours as we do. So I think before we start the roundtable discussion, I just want to do two things. First, one, just for records purposes, if we could just take a snapshot of this event. So if it's okay with us, can we just put on our cameras so that we just take a snapshot? I think all the panelists are now here. Okay. All right. Are we ready?
Yes.
One. Okay. One after the count of three. 1, 2, 3. Oops, sorry. I think I made a mistake somewhere. Okay. I used the wrong stuff. Okay. 1, 2, 3. Yes, I got that. All right. Thank you very much. Thank you. Any quick question for Dr. Moulane before we go to the roundtable on this science that is kind of talked about? Any quick question? Okay, it appears there is none, but let me just ask maybe one or two. First of all, what's the difference between asteroid, meteors, and comets? Is there any difference or they are all the same?
Oh yeah, that's a good question, and I sorry I did not cover that during the presentation because I used to explain that when we have a regular lecture, but now it's like as in this short. I should really like go fast.
Yeah, just
Yeah, so there's
yeah.
yeah, yeah. So asteroid is what we're explaining now. Is we call this a rocky, like we have terrestrial planet, we have also rocky small bodies, which we call them asteroid. Difference between asteroid and comets: asteroid it's a rocky object, but the comet is an icy object, which is made of ice and dust. That's the difference. And also they are located on different places. And this is can explain easily by their how much affected by the solar radiation. The one that closer to the sun, which is the asteroid, they are rocks, and the one that are very far away from the sun, which are made of ice and dust because they don't have enough temperature to sublimate that ice. We call them comets because they are made of ice and basically and dust, and that's the basically difference. So in terms of the risk or the we have asteroid have more risk than asteroid because they are closer to us than the comets. And also for when they get to the atmosphere, and now here we call them meteor. When they are already in the atmosphere, even an asteroid on a comet, when they are hitting the Earth or they're coming to the Earth, when they go through the atmosphere, at that moment we call them a meteor. But when they land on the Earth, on the ground, we call them a meteorite. And this is especially for asteroid because basically comets, if they are small, chunk of it hit the planets, they will basically sublimate in the atmosphere because there's a shock. It's going to happen between the object and the atmosphere. So when they come into the atmosphere, they will like burn out, and this will be happen quickly for comets because they are made of ice, and you know how much ice we can burn it compared, for example, to the rocks. So that's easy. So that's why I have different names. Asteroids are closer within the asteroid, a bit closer to the sun. Comets are really farther away from the sun, beyond Neptune, and they are made of ice. So any of them coming through the atmosphere of our planet, we call it meteor. When it lands on the Earth, like we will find it, and I maybe know some of you maybe have already found it or see it. When it lands on the ground, we call it meteorite, and that's different on names.
Thank you. And then another quick one. We are talking about threats, asteroid threats, but in your presentation, one of the distance you measured, maybe for the Apollos that is coming, was millions of kilometers away. So how close does any of these objects, asteroids, have to be to the Earth that they will now consider it as a threat?
Yeah, so the one that I have shown so far, we call them, there's like different categories, 4 to 5 categories. I don't remember the numbers, but they have different kind of orbit. There's some of them, they just really, their orbit is crossing. And this is not depends how much they are far away. Even the orbit is crossing the orbit of the Earth within our solar system. That's a potential risk, right? No matter how it's far from it. But there are someone that there is a minimal distance that they can go around the Earth without the gravity of the Earth gonna attract them. So they will go to the other side. And this is the minimal distance. I don't have the number in my mind. I have it in my presentation. But this is how we really classify this traits of this object, and we call them the near Earth object, means that they are near to our planet by its orbit or by its in its space, and that space when the gravity not like the moon, so the moon will not like impact us like something's behind the moon. But for example, this Apophis is coming now, it's coming between us and the moon, so it's like it's really like having some probability and to hit the Earth, but it's really low one. So because we still all the time making some precise measurement on its orbit by few kilometers in order to see really how much is we are safe on from this asteroid.
Well, thanks again. Thanks for setting the stage, for giving us this very interesting background. So I think we can go to the roundtable discussion now. And first, let me introduce the lead discussants. Like I said, it's a discussion interactive session, so we all get to speak. So starting with Naomi Frimpong. She's an astrophysicist, a science communicator, and leader in the African astronomy sector. She was a research scientist and head of science communication and outreach at the Ghana Space Science and Technology Institute. She has her PhD from the University of Manchester's George Bank Centre for Astrophysics in the UK. Her work has advanced the field of astronomy and the growth of scientific communities across Africa. She's also a former vice president of the African Astronomical Society, where she championed the development of astronomy across the continent and continues to do so, even now through her role as the deputy director of the International Astronomical Union Office for Astronomy Outreach. Next is my boss, Sias. So Sias Mustard, with over 30 years experience in spacecraft development and space enterprises, he's pioneered both in the upstream and downstream space sectors. So I mean, you can't talk about South Africa's space program without mentioning Sias. Because they started that whole concept, I think 1999 from University of Stellenbosch. He was the local organizer or local co-chair for the IAA Defense Planetary Defence Conference, which was held in May. The IAA, I think it's International Academy of Astronautics, if I'm not mistaken. And that conference was in Stellenbosch just this past May. He's a former professor at the Stellenbosch University, and he was the development manager for the SUNSAT program. SUNSAT was South Africa's first indigenously designed and developed satellite. Currently, he's focused on developing space infrastructure tailored to Africa's needs. He holds a PhD from Stellenbosch and an executive MBA from the University of Cape Town, UCT, which is considered as the best university in Africa. I mean, going through the ranking, and then David Kasibante is a space law and policy specialist based in Ghana. He is the team leader and founder of Space for Tomorrow, and I hope he will talk about what they do at Space for Tomorrow shortly. He has worked with the Ugandan government and other stakeholders to realize the full potential of youth in space sciences, law, and policy through research and development in the space sector. He currently serves as the Africa Regional Coordinator of the SGAC. The SGAC means Space Generation Advisory Council. And if you're a young person here between 18 and 35, I really encourage that you find out more about SGAC and join SGAC. It's a very good platform to get into the both the local and the international space community. So David has researched widely and published, majorly within the nexus between space policy, peace, and development. So thanks everyone again for joining. I'm really looking forward to the discussion. I think I will start with CS. So, like I mentioned, you're a co-chair for the IAA Planetary Defense Conference I held in May. Maybe we should start from there just to share maybe like an overview of what the conference was about. And I think this is the first time it was being held in Africa, if I'm not mistaken. And maybe anything you want us to know from the output of that conference.
Good day, Item, everybody else. Thank you for the opportunity to give some feedback on the Planetary Defence conference. I'm now a planet defender. If you host one of these conferences, you become a planet defender. So I was properly educated. Thank you so much for the fantastic lecture that we had from the first speaker. I can hardly add anything more to that, but I will come back to that. There's some African technology that was flying on the DART mission. You remember that last picture of the moon of the asteroid? Well, that was a South African supplied camera that was taking that picture. So we are in space. We even visiting asteroids. So the IAA Planetary Defence Conference meeting was the ninth of its kind. It happens every second year in a different part of the world. So 2023 was in Vienna, 2025 was in Cape Town, Stellenbosch, in fact, and then 2027 is in Canada. So if you want to join this community, and this is a very special, in my experience, it's a very special meeting. It's a meeting where the astronomers share the time in the auditorium with the space technology people. Somebody has to move the moon of the DART of the asteroid. And it includes the disaster management people, all in the same room. So there's no outreach. For everybody, this is very serious business. The other interesting thing that I experienced was the collegiality between all the people, and the focusedness and the commitment of this meeting. Even though it was such a diverse set of topics all in the one room. So we had 249 people in person. That was a new record. And we had 100 people online. And the online platform was such that you could present, ask questions, and interact with the conference. I was not skeptical, but I was amazed at the impact of how well it engaged. And then, of course, there was also an open YouTube streaming channel every day where everybody could participate, well, could at least follow all the lectures for free. I think I cannot recall the actual winner of the person that engaged the longest time online, but it was quite special. There are people that attended the conference almost every day for the full duration of the conference. There was another interesting thing about this conference is that everybody that can participate is almost allowed to participate. So there were 107 presentations. And that is a lot. So there's very good time management. Of course, there's also a very strong poster section in this conference. So posters and oral contributions are in other events that I've seen, there's some kind of status difference between the two. But many of the international organizing committee members actually submitted posters. Because that gives them a lot more interaction time on this. So it's a conference it's different in many ways. So the event was held for the first time in Africa. We had some of the space agency. Unfortunately, it was the same week as the event in Abidjan after the formation of the African Space Agency. So some people had a commitment in Abidjan that week of the conference, and that begs for better coordination. So if you ask me, what can the African Space Agency contribute? If they only contribute better coordination, we will all be happy about that. Yeah, so back to African technology. So what's interesting about this is that we have technology that is sitting at the L2 point behind the moon on one of the Chinese spacecraft that is providing a communication relay. But I think this is the furthest that one of our cameras from South Africa has flown all the way on the DART mission to actually take the last pictures just before impact on the comet. I mean, on the asteroid, not on the comet, the asteroid. So what was interesting to me was that some of these asteroids actually is just a loose collection of rocks. They were formed as part of, my understanding is they were formed as part of the formation of how things form in space. When it starts with a dust cloud, and then somehow there's seeds of growth where dust and later rocks come together. And some of these asteroids, if you would hit them with a rocket or an atomic bomb, they would just disappear into a cloud of rocks. And that was interesting to me. So I think the other interesting thing is, and this is that these asteroids detection become serious when they have a probability of larger than 1%. Now, this is the only place in the world where I know that 1% is significant. So suddenly one needs to take note of the small numbers in the universe. But in all, I mean, it's one of the most fantastic conferences I've been involved in organizing, and it's a very strong community. It's in the world. We had strong local organizing committee, yeah, looking forward to the next major conference in Africa that is building on the global collaboration of space.
Thank you, Sias. And since I still have you, like when I was introducing you, I talked about your engineering background, your involvement in SUNSAT, which kind of was the seed for the South African space program, and let me say the seed for many companies that we have today. You've been in the industry for quite a long time. So if you want to share, and following up from Youssef's presentation, on this issue of asteroid threat deflection and so many things, what capabilities still need to be developed, and what are the potential contributions that you think could come from Africa?
Well, okay, so I've been in the space engineering industry in the 90s, where if you wanted something, you had to design and develop and build it and test it, otherwise you don't have it. And then in 2000, we continued that tradition. At the end of that decade, it's actually, to build a satellite is difficult. To build a satellite business is much more difficult. So from 2010, in fact, from 2013, 2015, more or less, the global space market exploded, and in a good way. And suddenly it was the component. It was an opportunity to design and build components. In 2017, we launched our technology demonstrator, demonstrating the technology behind the cameras that are now possible even in nanosatellites. So today, Africa's contribution is most definitely sensors. We have, I listened to many mission proposals where some of the South African cameras are used to go and do an inspection visit to Apophis. That would be interesting, because then you don't have to crash into it. Flying by an asteroid is actually quite difficult, because it requires a lot of delta V. So I can see the everybody's trying to get a piggyback ride around getting close enough to the asteroid to make something meaningful out of it. I saw the Chinese recently propose they want to go and launch a swarm of nanosatellites to take pictures of Apophis. That's actually very difficult. You would need a very significant launch vehicle, dedicated launch to get that right. So sensors is where we can really make a difference. But public science is actually something that we were alerted to as part of the conference, where you with a network of cameras that can track where meteorites come in. If you can use 3 cameras or 4 cameras, and they all more or less look at the whole sky. But when you see a meteorite coming in, you can actually predict where it's going to fall on the ground. And I think what would be valuable for Africa, and of course everybody can participate in this, fireball cameras they are called. There's different groups in the world that actually also promote this and have some of these cameras. And I think having a fireball camera network in Africa is going to put our outreach onto a next level, because now everybody can participate. I mean, everybody. I mean, there's a lot of mathematics involved if you really want, but there's somebody else who's written the mathematics already. But just seeing a potential meteorite and it's big enough to fall on the ground and sending out a search party, that makes it real. That makes it extremely touchable and tangible, raising the awareness. And at the end of the day, it's about awareness. It's making people aware of what is possible and what are the risks. And then they will start thinking about how to solve the problem and preparedness. I mean, we had the Cape Town disaster management. They had the CEO of Cape Town disaster management as part of the lecture, and he was only invited to be on a panel, but he stayed for 3 days. And he explained, for a city like Cape Town, if they know that Apophis is going to hit Cape Town in 4 years' time, how on earth do you prepare for it? Because now you need to relocate some 4 million people. And I mean, there's a gazillion things that will go wrong and that is impacted, and it will make some of our refugee problems currently in the world. I mean, an asteroid hit will make that look like small change in terms of the scale and the impact and things that needs to be managed and coordinated, if it's possible. I think the outstanding threat comes from asteroids from behind the sun. That's how the last Russian asteroid that exploded above one of their cities were not detected because it came from behind the sun. So I believe there's a satellite mission being, I'm not up to date with the name of the mission, that's being launched just to go and sit on the other side of the sun and watch for asteroids, in case there's one coming from behind the sun.
Thanks, Yas. Just following up on that, I'll follow that with a question to Naomi. You talked about public science, and the question really is about, citizen science, as they call it. So what role can citizen science and amateur astronomers play when it comes to this issue of asteroid detection or response? It looks like something far-fetched, but like Sias has just pointed out, there are some things that could be done by, in quotes, lay people or amateur astronomers. So what do you have to say about that? But before then, you maybe want to speak about the African Astronomical Society. Tell us about them, what it's about, and how people can also be engaged with the society.
Am I unmuted? Yeah. Thank you so much, Etim, for inviting me to be part of this panel, and thank you to the previous speakers, to Youssef and Sias, for all that you've talked about. And I think it's really important that we know all about planetary defense and what globally is being done to mitigate it. And to start with, AFAS, African Astronomical Society, is a society that is, the vision is to create and support Africa to make it globally competitive, okay? So that the astronomy community in Africa, we have a voice, and we can contribute to the challenges Africa is facing, to contribute to the global science that's happening around the world. And AFAS also wants to like promote and advance astronomy in Africa. So AFAS has actually been very active for the past 4 or 5 years and has done a lot in promoting astronomy in all around Africa, and especially for planetary science and for citizen science and for astronomy education. They have done their outreach committee and education committee, and also the science committee has really been working tirelessly to make sure that everyone hears about astronomy in Africa, particularly with planetary science, planetary defense. I know that AFAS is working formally with the PAX E-Lab, which is a citizen science initiative nonprofit that has many citizen science projects, but one of them actually is detecting asteroids. And currently they have over 30 asteroids detected. And this is being done by young people who sometimes don't even have backgrounds in astronomy, undergraduates and graduates. So this is how effective citizen science is and how much AFAS is supporting citizen science. And currently AFAS, I think, was it 2003, 2004, became an observer of COPUS, which is the Committee for Outer Space Affairs. So they are really be given the opportunity to contribute to the global decisions made about outer space, and also the defense of planetary asteroids and all those important issues that come up that have been decided, globally now. Africa has a chance to be, have a say in what's being decided. Now, to your question about citizen science and amateur astronomers, Africa is currently, not as well involved in astronomy as we would like, or space science. And with the African Space Agency now, organized, and with efforts of AFAS, people are now seriously knowing more about astronomy, and citizen science plays a big role, especially amateur astronomers, because we have a very young continent, very vibrant young people who have interest in astronomy. Even though we don't have a lot of observatories, we don't have a lot of trainings in universities don't run astronomy courses or space science courses, but citizen science brings astronomy and space science to their doorstep. And once the community and the population is educated, they are well prepared for anything that's happening. So if you want to talk about the fear that comes with asteroids and asteroid impacts, citizen science and amateur astronomers actually help people to prepare and actually get them the right information, because we know that because of fear, there's always misinformation, and also there's disinformation. People actually try to turn the truth around for their own personal gain or political gain or whatever. But outreach, public engagement through citizen science and amateur astronomers are very important to helping curb this kind of misinformation or disinformation, and getting the public ready and aware of what's globally is being done to mitigate asteroids impact, and to alert globally the alert systems that have been put in place globally to mitigate asteroid impact and planetary defense.
Yeah, thank you. Citizen science, what really does it mean? Because I know some people may not understand what you mean by citizen science. So what does it mean?
So citizen science is when you bring people who normally will not have knowledge, they've not been formally trained in an area, to help you to work with the data you have, and to help you to make deductions from data you have or research that you've done. So especially for why it's so important in astronomy is that astronomy is such a data-intensive science. We are looking like billions of galaxies, you're looking at millions of asteroids, and our telescopes and observatories scan the universe and come up with like billions of data, gigabytes of data. And the astronomers alone cannot sit down and check or work with this data. They also have things to do, or they have more research to do, or write more grants. So they come to the citizens and say, we have this data, we have these tools to help you understand the data. Can you help us, look through our data and bring out information that we might have missed, or because of time, we don't have enough manpower to work with this data? And citizens and people who are enthusiastic about astronomy and happy to help and to contribute to the science take up this challenge and contribute to science. And they come up with amazing results. We know they've done amazing, especially PAX-E lab has. I've seen their presentations at the IAUGA in South Africa last year. I saw them presenting at this year's AAS in the US. So they are doing amazing work, and I really recommend them for the work they are doing.
I need you to give some more clarification. So Sias mentioned public science. So there's public science, there's citizen science, there's amateur astronomers. Are they the same concept, or there's difference between them?
So amateur astronomers can be part of citizen science,
Okay.
and public science can be also part. I think it's, I don't know where it's coming from, but I think it's also citizen science where the public is involved in the science. So I think it's the same thing, but amateur astronomers may be doing their own thing. They can be in their own community doing their own stargazing or doing research on astronomy, but they can also be part of a group doing citizen science global campaign that is doing. They are looking for one particular result or data for the scientific community. So that's what I'll say about the difference or the similarities between them.
Yeah, thank you. Now, to what I find out to be one of the very interesting parts, and I want to bring David in now. I just want to give you some minutes to just talk about the policy and legal ramifications of this whole idea about asteroids, starting from maybe even identification, tracking them. I mean, if you want to classify it as threats in space, threats in the air, threats on the ground, but just give us a broad picture of what are the policy and legal ramifications of this whole issue.
Right. Thank you so much, Item, and it's always a pleasure to be part of these conversations with ASLI and other colleagues. So you asked a very interesting question, because when we're talking about legal and policy frameworks, oftentimes we think of them in such a way, we think of them in forms of laws, right? And bureaucratic policies that have been decided somewhere and are supposed to be imposed somewhere on others. However, when it comes to something like planetary defense, there's a lot of gray area. It's one of these areas within space law and policy that is very gray, that's still largely gray. This stems from the fact that, when we are talking about law and policy within space, we're mostly talking about international laws. Largely, that's where it comes from. It's international laws, how states engage with each other, right? Because space is recognized largely as this thing that is owned by everyone, which we call the common heritage, or the heritage of humankind, right? So the laws that were developed in the 60s and 70s, which we call the outer space laws, there are about 5 laws, 5 treaties that were, negotiated between different countries. The Outer Space Treaty, the Return and Rescue Agreement for astronauts, the Liability Convention, the Registration Convention for Space Objects Launched, and the Moon Agreement. These, of course, were bolstered by a few other what we call soft law instruments, which are like declarations and debris mitigation guidelines and that kind of thing. However, we are yet to have a law that specifically addresses what happens if the planet is in chaos from an outside force. Because the laws that were negotiated were mostly what human beings shouldn't fight in space. Human beings shouldn't do this in space. Human beings shouldn't do that in space. And that's well understood. However, what happens if the threat is from outside the Earth? There's a bit of a gray area in that way. So the question of asteroids and planetary defense is still quite developing, I would say. We are yet to have a concrete understanding, and this, of course, comes from the nature of obligations that states have towards each other when they're dealing with space-related things. And the nature of those obligations is such as, for example, the Liability Convention. It requires that, states are absolutely liable if there is damage that is caused by their object within the Earth, okay, within the atmosphere of the Earth. If it comes out of space and it, if someone launches, let's say, a rocket, and as it re-enters, it doesn't fully burn up and it causes some kind of damage, then that state will be absolutely liable. But then, of course, if damage happens within space, then the liability is a bit convoluted, but the state will still be liable only if it can show that the damage was due to something that it did, due to its own object. Now, the nature of that liability is very high, and the scientists here can confirm this, but space missions, space engagement is extremely expensive, and there's so much at stake. So that said, when you are dealing with something that no state has any particular control over, many states will be a bit reluctant to extend their help just in case that thing should cause damage and they could become liable. So, for example, if there's this, let's say, Apophis coming, and let's say it's going to hit the Earth, right? And it's detected, and high probability it's really going to cause damage, right? If any state says, oh, let's launch a rocket at it and dismantle it, right? And should that mission fail, and that rocket somehow, let's say, misses or it hits, but then some damage is created due to the rocket hitting the asteroid, and let's say pieces of that asteroid fall down and cause damage, some other states could simply claim, hey, you caused us damage. It's you who did this. And that's a very, very expensive claim. So many states would be a bit reluctant to do something like that. The other problem that we would have is agreeing together. The international community is still, in a way, fragmented when it comes to some of these questions. Coming together and agreeing on a common objective and saying, let us create this system that is going to help the planet, and let us all contribute to it, let's say in equal measure or in some kind of ratio. It's still a bit difficult. If you've attended the UN Corpus meetings, especially the legal subcommittee, you'll notice that attaining consensus is always troublesome, very hard to gain the consensus of states to do something. So that bureaucracy could actually cause even, more delays. And that asteroids are not really going to wait until, the bureaucrats have somehow, agreed on a common stance. So that bureaucracy could cause issues. However, if we are looking at Africa, what can Africa do? What is Africa's role here? I believe that Dr. Youssef mentioned something in his presentation, that just like climate change, it doesn't really matter, because at the end of the day, we will still be affected, by issues of, you say, falling asteroids or things like that, or meteors and meteorites. Therefore, Africa right now, I believe, and this would be within, I mean, it's something that I've been trying to sort of flesh out, that Africa is at a watershed moment where we do have the opportunity to shape a huge aspect of space law and policy, international space law and policy, especially regarding these nuanced and these new aspects that would affect us a lot, even though we may not necessarily have a very huge contribution to their happening, right? So things like planetary defense. With the new African Space Agency, we have the opportunity to create an a collective African voice on a planetary defense framework, for example, right? One that would, incorporate our views and our ideas, and we can even present this as a block argument, let's say in international fora. And then, of course, we do have these regional emergency responses, right? Africa has a number of regional communities, the ECOWAS, the SADC, the ESC. Within those frameworks, there can also be discussions. I know, for example, that in the East African community, we are having discussions around sustainability, and this question of planetary defense is coming up, right? And we can start, from that silo place, but then also grow and develop even further. I think it was Professor Sears who mentioned, this conference that just finished in Cape Town. Having such fora would be quite, I believe it would be quite an opportunity for Africa to show, what ideas we have and what we can do, and even showcase our own, technologies, like the South African cameras and the technologies that are developed on the African continent that can be important or that can help the international community. So I believe that conclusively, with all the ambiguity that exists currently in the legal and policy framework regarding planetary defense, there is still the opportunity for thought leaders, not just on the continent, but also off continent, to come up with a compact, okay, that illustrates a global or a globally focused initiative that would help humanity in the event of impact. We have done this before, kind of. You can see from, for example, the ISS treaty, the Treaty on the International Space Station, which brought together literally warring parties for a common good, and I believe you see the AU, the African Space Agency, and these different entities that have come up, they all illustrate that there is a possibility, and it's possible to come up with a consensus and a global compact, especially when you think about it from the fact that everyone would be affected, or large swaths of people would be affected in case of impact.
Thanks, David, for that broad overview of the policy and legal implications. I know this is kind of not an easy topic for everybody, since it's planetary defense, asteroids are not things that we discuss frequently or every day, like other topics. But if you have any question or any comment, any idea whatsoever, you can contribute to the discussion through the chat box, or if you raise your hand or anything, so that we can have a robust interaction. So let me come back to you, Youssef. What do we need to do, or what do we need to start doing in order to be kind of a bit more prepared now that we know that there are these asteroids with a lot of threats, and some we don't even know, like Sias mentioned, the asteroids behind the sun. So what do we need to start doing?
Yeah, thank you very much, Etienne, for that question. So there is a lot of things to do, as I mentioned during my presentation. So, and as Africans, so
And maybe I should just
also...
sorry for interrupting. And since you're an academic, maybe some more emphasis on from the academic angle. What should the academia, students, professors, researchers, what should we be doing?
Yeah. Yeah, there's a lot to do. So even in the academia or industry. So this is a very topic that it's really incorporate both the academia and industry. But since I'm in academia, I will be talking more about research. So one of the most important thing that we have to do at first to identify and find this object, and that's the first step that we have to really concentrate on. So, and now we have, as I mentioned, the new LSST or Auburn Observatory just been launched like few days ago, and it's found like the first shot. It's found more than 2,000 new objects, and this is so. We could be as African within the universities to be involved in this kind of project, and the data it's open to everybody. So we have to look at the data and try to work on it in order to characterize this object, because this is very important too. So not only finding them, but also characterizing them. So it means that we have to determine their physical and their chemical property, what they made, classifying them, classifying their size, and all of this. So there's a lot of things to do in this. And really, so we organized the last AFAS conference in the South Africa, or even the one that before in Morocco. So we dedicated a session about the planetary science. Unfortunately, we did not get really like huge feedback on that in the community. So especially the African one. So we don't have that. Many people involved in that within the African universities, and this is what we really encourage them to do. So like, if you don't have like, we collaborate, because we have some places you do, some places don't do. So this is one of the most important science cases that we have to address within our universities. And this is really for professors and for researchers working on the topic. So trying to collaborate with other people, like having small telescopes. For example, I did not mention today during my presentation that Camden Observatory in Morocco, we have small telescopes. They're really dedicated to finding new objects. And we have done so. We have found many. We have found like 9 new objects from Morocco and 4 new comets. That's imagine other. I know that also in South Africa there is some project dedicated to that. So there is a lot of things to do in terms of research for finding and characterizing these objects. I know that our infrastructure in space now is not at that level. So except if we're considering African countries, and the African Space Agency, we just established it like a few months ago. So yeah, so we have to maybe start with this aspect to look at this finding and characterizing this object, and in parallel or with other people who are working also on the technologies, as I mentioned. So especially the South Africans, they have already been developed on that. So we can help other countries within Africa to be first. This is awareness, and then trying to do really some serious research on this object, especially on this in the term of the characterization. And for that, we don't need really like a huge budget to that. So small telescopes are not costing much. So and this is in the map of the world. So we have that gap of African observatories. So if you accept now South Africa and Morocco, so there is nothing between. I mean, professional observatories look at this object, and when you are different location within the Earth, so you might miss some asteroids. So this is why we have to cover the whole planet with observatories. So this is why we have LSST, which Auburn Observatory in the south. We should be also like fighting to get a new LSST in the north hemisphere, like in Morocco or in other places. So to cover the whole sky, to get this max of possible of object that we can. If we miss only a few or one, that one might hit us. So that's the problem. So we should really maximizing our coverage of the sky, monitoring the sky as much as we can in order to find asteroids, and not only to find them, but also to classify them and to study them, and also to coordinate with other partners and collaborators around the world, like from Asia, from US, from Europe, to do this effort of the planetary defense. And this is the main area that we should working on.
Yeah, thanks, Youssef. Sias, do you want to speak from an industry perspective?
Yeah, so in Africa, I am aware that there's been a number of space programs very successful in various countries in Africa. We've been working on the African Resource Management Constellation since the early 2000s. So in Nigeria, Algeria, Kenya, there are long-term commitments to space. Of course, Egypt has joined the African space race recently, and they also hosted the latest New Space Africa conference. So in Africa, there are a lot of budding potential in terms of contributing from the industrial base to the international community. Yeah, we recently had in South Africa, we had some interaction with various international stakeholders who are actually looking for Africa to be a part of the international community from an industrial supply chain perspective. So I think the future in that context is bright. Of course, Africa still has the one little hurdle to overcome, and that is access to space through a dedicated launch vehicle. Because if you don't have that, you can actually be everybody else can conspire to make sure that you don't get into space unless you have a local launch capability. So that's also something that needs to be developed as part of the overall African attempt at being a member of the international community in this respect.
Yeah, thank you. Naomi, from the professional associations or civil society?
Yeah, thank you, Etim. So from where I'm coming from, being in the public engagement sphere and from the African perspective, from AFAS, I think spending more attention on public engagement is very important, starting from media. Everything we're doing, whether internationally or in around our continent or locally in the government sector, if the media does not send out the right message, the public will not understand what the government is doing, will not understand what globally is happening, and might not support. And all governments run on support from the public. So if the media is not well informed, it always brings some issues with how the public views the efforts of the other governments or international organizations. And educating the media is one of the things that needs to be done and done well, so that they understand what is at stake and what they need to communicate with the public. Also, in terms of education, AFAS has been supporting a lot of astronomy schools around Africa, and I think it's something that governments and also international bodies should buy into, to educate the young people, to get them ready for the astronomy community, to get them ready for the future of what Africa can do in the space sphere. Because we always have the old wise people leading, but if the young people are not being trained to take up the positions, I think we'll always find that there's a gap between what is being done and how the young people are being groomed to take up these positions and to push forward the agenda of Africa's position in the global sphere. And also, public engagement to schools, to the public is really, really important to get the communities and the public involved, whether through citizen science, whether through amateur clubs, astronomy clubs. It's really important to get the public's buy-in into planetary defense and astronomy in general. So that's where that's my contribution.
Yeah, thank you. Carla, I see your hand up. I'll call you shortly, but let me just put the same question to David. And I'm just imagining, supposing there's an asteroid impact on the Earth. I mean, just imagine the scope. So governments are involved, people are involved, insurance companies, international, it's a very wide scope, so to say. So I just want to also contribute what should be done, or what should people be doing, what should the government be doing now, just to be on the safe side.
Right. So thank you. Now, I believe that in case of such an eventuality, already right now we have some few entities that have been created. You have the Space Mission Planning Advisory Group, and the International Asteroid Warning Network. And both of these are still, they don't have any binding power. They don't have any actual, binding authority. They're still quite amorphous in how they do their work. I believe that what we should be doing now is strengthening or creating such entities and giving them some kind of capabilities in case of such an eventuality, right? Giving them, say, if you want peace, prepare for war, right? If we are saying, we want to prevent catastrophic effects of an asteroid impact, we need to start preparing for it now, so that we do not then rush when it happens. Oh, this one should do this one should do this. So even within the African the African Space Agency, I believe there should be an entity therein that specifically is preparing for such an eventuality and is properly equipped. It has the scientific, the scientists are there, the physicists are there, the emergency response people are there, and the legal people are there in case of any legal questions. So that in the case that such an eventuality happens, at least there's somewhere we start from, rather than starting to build frameworks while the actual event is happening. So I believe this calls for all hands on deck. I believe it calls for an interconnected and multi-sectoral, multidisciplinary approach. Okay, so that the scientists are not working in silos, and the legal people are also working in silos, and the physicists are working in silos. That there should be a kind of coordinated mechanism for all these different important people to be in the same room to come up with these frameworks in case of such an eventuality.
Thank you, David. And while I still have you, Space for Tomorrow, what was it about? Is it connected to planetary defense in any way, or is it about sustainability? What do you guys do at Space for Tomorrow?
Yes, thank you so much. I should have mentioned earlier. So Space for Tomorrow, right now we have not yet started focusing on planetary defense per se, but Space for Tomorrow is a group of young people with a passion for space, right? It was created after discovering that there was a mentorship gap in space within Africa. In 2017, after I did a certain competition in South Africa, only to come back to Uganda and discover, there actually is no one we can talk to about these things. Most of the people who we knew were non-Ugandans, or they were even non-Africans. So we created a network to sort of empower ourselves, wherein we started bringing in different people to mentor and to work with different youths who are interested in space-related activities. And right now, we have grown the network, to include even, non-Ugandans, and a number of other people have come in. So what we do is mostly identifying mentorship opportunities and then building on those mentorship opportunities so that the different members can actually get, an actual future within the space industry. Because before that, when you said you're a Ugandan or even an African for that matter, and you say you're a young person, you have a passion for space, I'll be like, and where are you going to do that from? Usually the question would get, we have potholes. Where exactly is your head up in the universe when we still have potholes on the, in the city? So it looked quite bleak for a number of people as to how they are going to use the knowledge they have acquired to develop actual careers within the space industry. So Space for Tomorrow was developed to help them on that journey, and as a result, also come up with different engagements that can build on the conversation within Uganda, Africa, and the world at large. So that really is what we are all about.
So from the discussion we've had now, do you see any prospects for young people in the planetary defense field? Do you see any role for Space for Tomorrow? The colleagues at
Absolutely.
Space for Tomorrow in the network.
Absolutely, absolutely. We have a saying in Uganda, in Luganda, that the young trees are the future of the forest, right? That every time we look at young people as non-participants, as nothings really, and we leave most of the decisions to the older people. I'm not saying that older people are bad. In fact, I believe that there is a lot of wisdom to be gathered from that. But a big part of the future belongs to those who still can get it, who have the energy, who have the zeal, who have the freedom to be curious, the freedom to still dream. Most of us, when we get older, we tend to lose that curiosity, and we tend to be, put in the box of what we already know. But younger people can still dream. They can still come up with pretty good ideas that could propel the future, ahead. So I believe that even with planetary defense, young people should be on the table, because I mean the planet is theirs. Tomorrow they are the ones who are going to have to come up with hard decisions, when things like this are happening. So yes, I absolutely believe young people should be on board for these conversations.
Okay, so thank you. Carla, maybe as a brief introduction, Carla works with the SKA. I actually wanted to bring you in. I actually have a question for you relating to the SKA. So she's the Africa Program Manager for SKA is the Square Kilometer. No, sorry, I'm making it up. She works with the South African Radio Astronomical Observatory. And then, of course, there are people that are overseeing the SKA. But she also has a project called the Africa to Moon Mission, which invariably, or yeah, is going to be Africa's very first indigenous mission to the moon. Carla.
Hi there.
Yeah, good to hear you. You're
Before I
welcome.
comment, what is your question for me?
Okay. So I actually had two questions for you. So one, when Youssef was talking about the gap between Morocco and South Africa, that there's a gap in terms of monitoring. And the question had to do with the SKA. So I was wondering, since the South Africa has about 8 or 10 partners, which in terms of African countries, what is there any role in terms of filling this issue of planetary defense? Is there any role that the SKA is playing? The partner countries, is there any role they are playing in terms of filling the gap between Morocco and South Africa? That was the first question. And then the second question had to do with the Africa to Moon mission. You can also share what it's about. I'm also wondering, I know the project has to do with the moon, is I think the south side of the moon. But is there anything about any role that you see that project playing when it comes to planetary defense also?
Thanks. So first I want to say thank you to everyone for your very interesting inputs. And Sias, always good to see you again. It's been a while. So I just wanted to comment on, I agree. It's, the governments interact by bilaterals, and the agencies are dealing with one another, the African Space Agency now, and organizations, as was pointed out importantly, for outreach and for young people to get involved. But a point I made in another meeting is that we used to have the South African Space Association, and I think it's time again to rejuvenate that, and perhaps an African industry association, because it's important that industry is able to interact with one another on a basis, one, to be able to represent industry to government in decisions, but also industry, they're moving forward. They have a lot of capability and innovation. And when you're faced with a disaster, particularly where you're talking about planetary defense here, it's useful to have a central points that you can access industry quickly to see how they can contribute. So I just wanted to throw in the hat as well, the importance of rejuvenating these industry associations. And then in terms of talking about mentorships, etc., we found with our education program, which has been very large and very successful at Sereo, one of the challenges we have is once people are educated, where do they go work, particularly in the space science fields? And so by partnering and having one voice in industry, you're able to access potential for mentorships, internships, etc. Then on your questions, so the SKA, we have 8 partner countries in Africa where we're implementing human capital development and infrastructure projects relating to radio astronomy and relating to big data or data intensive analytics, that area is equally important. There's no use in having data if you're not able to use it and develop applications and solutions. And we have a number of associated programs, still a co-location program where we're looking to co-locate science facilities with satellite ground receiving stations so that data can be shared more easily. As CS pointed out, we have access to data, but we don't have autonomous infrastructure that we control, that we're able to obtain the information when and where we need it. So this is being addressed more and more with satellite capability, but equally launch capability, and then importantly, the compute capability. So we are not limited to those 8 partner countries. We're just limited in our contributions of resourcing. So partners who want to come on from other countries, that would be welcomed and encouraged. Africa to Moon is a radio telescope we designed for the moon. It's a ball-shaped instrument, and we hope in the end to put 55 balls on the far side of the moon, each one representing a nation in Africa. Together, they act as a radio telescope. The first mission, we have been accepted on a Chinese Chang'e 8 mission to the near side of the moon, and we will be sending a technology demonstrator. This will be the first radio astronomy array on the moon's surface, designed and built by Africans, and it will do first-time science. So this is due for landing on the moon in 2029. This is important for a number of reasons. But the science we'll be doing is science that we can't reliably do from Earth because of our ionosphere. And we've actually submitted a proposal to put one of these on a Mars orbiter so that we can look at doing science between a very long baseline interferometry between Mars and the moon, which has also never been done before. So this may not have direct impact, although we don't know what we'll see. Maybe we can see stuff in low frequency that helps with planetary detection for protection, but I think every innovative step forward will ultimately lead to solutions and solving problems on the ground. So I think what I'm trying to say in total is the more we collaborate, the more we open communications within Africa, developing, as was said, indigenous value chains and working with one another. Each of these steps forward will help everyone take a larger step forward. And I think ultimately that will be applicable to planetary defense. SKA is not specifically doing that, but I'm sure that with our instrumentation and expertise, that contributions can be made where we faced with a crisis. Thanks. I hope all of that answered the questions and that I made sense.
Very well, very well, very well. Thank you, Carla. And looking at the chat box, I see a comment by Natasha about the role that the public can play, the importance of coordination, and the need for more support for planetary defense initiatives. And then there's a question from Vanessa. In cases of real threats, are there protocols for evacuation planning, impact modeling, or humanitarian coordination for affected regions? Yeah, this is an interesting question. Who wants to go for it? Youssef? And then maybe David.
Sorry again, I missed that one.
So in case of real threats, real asteroid threats, Are there any protocols for evacuation planning? You know, I think your last slide showed the potential, supposing it lands in a major city. So are there protocols for evacuation planning? Is anything around impact modeling going on? Any humanitarian efforts, any humanitarian coordination for affected regions? And I don't know whether this is supposed to be both at the local and international level.
Yes, so for now, there is what we call this alerts that is released by the International Astronomical Union. So within its office, we have like kind of office dedicated to that. It's making some alerts. That alert is basically not made for people, but just to know everybody knows about this and maybe some risk for a given asteroid. But the for the public or the protocols of the evacuation and so on, we're not at the stage yet. So of course, if we know there is something and we identify when it's going to hit, of course, the authorities of that country or that region should be really taking care of that. It's a matter of it's a local thing. So it's not, but we are not at that exercise yet. But I think within this community of the International Astronomical Union and especially of this asteroid impact alert, so they are working on this kind of protocols. So when we identify a place when it's got maybe some hits of an asteroid, so we should maybe follow in this protocols. But as far as I know, there is no thing like written in for everybody, but yeah, they are working on that. So in the future.
Thanks. Any other contribution to the question? Any other thoughts? The issue of modeling, yeah, David?
Yeah, maybe. I could also mention that right now, what exists is that there are some protocols that have been developed, but most of these are at a national level. So different countries come up with different disaster preparedness protocols, how they will approach a particular subject. And so if you were to think about it, for example, currently you have some protocols under in the US, for example, NASA and FEMA have these tabletop exercises that they've been practicing since 2010 in case of such issues. So they're specifically designed around situations where deflection is impossible. And then, of course, you also have some research that has gone into evacuation zone determination to see in case of such impact, which people would have to evacuate, which zones would have to be evacuated, that kind of thing. And then, of course, we do have some existing scientific prediction infrastructure. Because I know I did some work recently with some colleagues from the Lawrence Livermore National Laboratory and the Sandia National Laboratories, who said they have some kind of technology that can currently sort of predict impact footprint, create models for this kind of impact footprint, population displacement estimates, and that kind of thing. So those kind of exist. But then, as I said, on a national level, most countries have some kind of disaster management coordination mechanisms. And all we need is to have coordinated transnational, multinational mechanisms in case of such disasters. In case a country that would be affected had no way of knowing that it would be affected, there should be some kind of early warning systems that can be provided by another entity that could be able to detect and bring this bring this knowledge to this would-be affected country, which would then carry on some kind of drill exercise that would be indigenous in their own settings.
Excuse me. Naomi, since you're a bit more involved in outreach, I was just wondering, do you have any thoughts around this, especially when it comes to humanitarian coordination, especially from the public?
Thank you. I think it's very important to get all avenues involved, from the media to the academics to the general public to the science communicators, because knowledge needs to be spread everywhere. So when I talk about the educators, I'm talking about teachers, lecturers, teachers, basic school, teaching people if we have each kind is a protocol of how to evacuate or how to mitigate. These things should be taught from the bottom to the top. And when the students know, and when the children know, and when the young people know, it's disseminated into the families and goes into homes. Because that's the public, okay? From the children, and sometimes getting to the parents or the adults may be difficult because maybe not everybody has time to listen to the radio or not everybody has time to pay attention. But when it's being discussed at home, then the message is being spread. Because we have protocols for earthquake evacuation, we have protocols for flood evacuation. On the regions that those things happen, like tornadoes and everything, they have protocols. How do they disseminate it? They use it, they discuss it from the schools. From the schools, then to the workplaces, and then the government does a whole like national broadcast to media. So it has to be done simultaneously from the top to the bottom, from the bottom to the top. It has to be well planned. If there's something like that happening, we have to really have our plan done down, and to make sure that every area is being covered. And the best place I always say is from the schools, because that's where it moves into the homes. And once it's in the homes, the public knows. And once your media has the right message also, then there's no misinformation or disinformation to counter whatever plans the government is making. So it's very important.
Yes, thanks. I think we'll just use the next couple of minutes to do a simulation activity. But before then, I just want to mention about, I think it's called the 100X declaration. I've been trying to log on to Asteroid Foundation website, but I think maybe there's a lot of traffic there today, so it's just not coming on. But maybe we already know about the 100X declaration, which has to do with like a commitment to be part of identifying asteroids. I mean, the different that value chain, that process of avoiding the threat from asteroids. So identifying, is it naming the asteroids, and that whole length. So if you check the Asteroid Foundation website, the declaration is there. And I think there's even something like it's like a signature, but of course it's not your normal signature, but just a means of showing that you're going to be part of the whole process, so to say. But before I call Youssef to lead us through the simulation, I just want to see whether I can play one of the like a video. Yeah, I was checking I don't know why the site is not coming up. Thanks. The site is not coming up, maybe from my, okay, it's up here now. Let me see, can I get to Asteroid Day? Let's see. Okay, maybe Yusuf, maybe when you come up, you can also show if you have the 100X declaration open. But I just want to play this by one of the co-founders of ASLI. He passed in February. That's Dr. Abiodun. Let me see.
So if you have the link, you can maybe send it to me. I can play it.
Oh, okay. Let me see. Let me share my screen from here. Share. Let's see. I believe you can see my screen.
Yes, we do.
So I just.
I am Adigun Ade Abiodun, retired United Nations expert on space applications. I'm former chairman of the United Nations Committee on the Peaceful Uses of Outer Space. I signed the Asteroid Day 100X declaration because we have to work together to protect our home planet and all its inhabitants from the potential impact of asteroids.
So I hope you heard that the sound was a bit low at my end, but you can check the website and you can check the asteroidday.org. So you see several, you see several
Chief of Astronomy.
Several scientists, several people who have signed the declaration. And then you can also identify with that. Okay, Youssef, over to you now for the simulation activity.
Yeah. So in the last few minutes of this program, so we will have a simulation of impact from an asteroid with you choose a place. So I will share with you in the chat a link. So all you want to do, you just to go to this link, and I will share my screen to show to you what you're gonna do. So when you open that link, you will see this screen like this one. So on the right side, so I want to make sure that everybody is on it on this website. You just click on the chat, you click on it, it will bring you to this. You don't need to install anything, nothing. You just click on that website, you will get this website. It's called Asteroid Launcher. So on the right side, you will have the type of asteroid you're gonna launch, and it will hit a place and will give you some estimation, how many people will be maybe get killed within this place, what the damage will cause this asteroid, and so on. But there is some free parameters to play with if you want to do so. So there's the diameter. If you want to make your asteroid big or small, you can play also with the speed, which speed this asteroid is coming with, and you can also play with the impact angle, which angle this asteroid is coming on. You can also change the object or the type of asteroid. I did not talk about that during the conference, but we have different asteroids. We have the iron asteroid, depending on the composition. We have the stone asteroid, we have the carbon asteroid, and we have comets. And you will see the difference because the comet is not like asteroid, as I explained. So all you're gonna do is gonna choose a place when you wanna hit this asteroid and see what is the impact we're gonna do. So I don't know. I have done did the many exercise, but you can choose whatever place. I maybe choose a city where I am now, or you can choose that too. So to see where to see the effect of that. So the city where I am is somewhere here. Yes, it's here, Spingeria, where the university is located actually. Oh, that's actually, it's the campus of my university. We are here, the city is here. It's a small city near to Marrakesh. So you can try that on your own city or your own preferred place if you want to do so. So all you do, you're gonna just choose a place, click on it, and then you choose also the object. And I will choose this stone asteroid, and I will click on launch asteroid. So you will see that, something like this. And that's the creator that will create it if I launch this asteroid with this characteristic that I have seen. It will create a 4.3 mile wide crater. So an estimation of almost 60,000 people will be evaporated in the crater, which is almost the entire city, which is the population of my city for now. The crater will be at 1,700 feet deep. Your asteroid impact the ground with like 37,000 miles per hour. And the energy that will release, it's 4 gigatons of TNT, and so on. So you will get also the wind that will be created by that impact, and also the shock wave on all these characteristics. So the wind, sorry, here is we're talking about the fireball. So like the combustion will happen, and what is the degree of that, and all of that. You got also the shock wave. It will happen during this area. So also the winds that will generated from this impact. So we're talking about also this wind will be like more than 200,000 people will die from that wind blast. And all the characteristics here, you can see also the magnitude of in terms of magnitude of earthquake, like a 6.9 or 7. This is a really serious thing if we got that. So yeah, this is something you want to like see which damage can an asteroid cause to your place you choose, whatever you're trying to do, all this stuff. And all of these things are estimation and based on some science data that we have seen, like for example the crater that we have and their diameters and so on. So you can again click on Roulage asteroid. This time you can choose different thing. Like let's see what's happened if you choose a comet. So and you can compare things. So and you see the crater of the comet is smaller than compared to the asteroid, and this is, you might ask why, because the comet, as I mentioned during my presentation, because it's made of ice, so the impact will be like smaller, like compared to the asteroid. Especially the most of the material, the comet will be already evaporated in this when it's entering into the atmosphere, because it's ice, not like asteroid. And this is if we're asking to get hit by an object, we prefer a comet than an asteroid. But both of them, even this one, will create like a 2 mile wide crater, which is almost half of the asteroid one was created. It will kill almost 25,000 people and all these other characteristics you can see here. So no one of them is it's easy to deal with. It's still a problem. So you can always play this again. You can choose different other cities. So for example, if I choose Marrakech this time, so and this website, it has some information. So I will change again. So let's change this, for example, this time the angle, and also let's increase the diameter of this one. So like a big one, and let's make a stone one and see what's going to happen to Marrakech. In this case, if I look, the whole city will turn to a crater, which is like 5.8 mile wide crater, so which is like almost kill everybody in the city. So and you see all of this other characteristic that we have been going through now. So this is, I think it's a very educative and informative tool for people and for teachers to use with students and with kids, and also in the education, to show them what is the result or the consequence of if we get hit or we can an asteroid hits a given place. You can also choose the I did not mention that you can also choose a part of the like some cities within close to the ocean, or you can choose even the ocean. For example, if I choose Casablanca here, one of the biggest cities in Morocco, and I choose somewhere here close to the ocean, so you will see also the tsunami that the crater will make on this on the city. So and so on. So yeah, there's a lot of things that you can play with. So and so on. Imagine if we got this wind on in the ocean, so which kind of tsunami will be created by the whole city and so on. So yeah, as I mentioned, this is a very nice tool for educators and people working on the education and outreach programs to include that. It's a free site you can use, and you can apply to any of your cities or any places around the world. So just to see which kind of estimation of the damage that can pose by given an asteroid and so on. If you have any questions related to that, so yeah, feel free to let me know, and we can talk about it now. But I would like you to try it by your own on your laptop, so on your preferred places, and you all can play with these parameters that you can see here, and you can do different exercise to play with. So you can increase the speed, the impact, the diameter of the object. Even you can choose like a smaller one, and you will see, for example, if you put in a given country, so you will see what's gonna happen. And so yeah, so if you have any questions, I'm now almost, I think we're done with time, but if you have any questions, I'm free to answer that. So up to you, team.
Yes, thanks, Youssef. I think we can kind of sorry, would you like to, can you stop sharing? I want to see whether, sorry. Okay, yes, thank you. I just wanted to see whether Sias was here, but I think he stepped out. Okay, Sias is still here. Yeah, so as a roundup, I just wanted to put maybe a final question maybe to Sias, and maybe any other person can contribute also. The IAA conference is done. Now it's moving to Canada next 2 years. I'm just wondering, so within Africa, what happens when it comes to planetary defense, the discussion? Where do we move on from here? Or do we just wait until the next IAA and then we all go to Canada, talk about it? What maybe it's one of the outcomes from the conference, but what's really on ground within Africa going forward from here? Just briefly.
That's a very good question. So it is a topic that is definitely on the fringe. However, I think the public awareness is being raised by movies like Mighty Pups, Paw Patrol. The villain in the movie actually attracts asteroids. I see there's a big smile in the middle. The villain actually attracts asteroids to Earth with a big giant magnet, and then the crisis is being created by asteroids hitting the Earth. So I think for Africa as for everywhere else in the world, it's a topic that is it is on the fringe of public interest until you see one coming. And of course, we never know when one is coming. I mean, it's like how do you predict a tsunami? It's actually quite difficult. But for Africa astronomy, it is the perfect vehicle to encourage astronomers to not only detect it but also to characterize asteroids. It is tough. It is very tough. I saw what people have been doing, but we've heard two of the speakers already talking about astronomy, making it competitive in the global market, and that is asteroid detection and characterization. Is that it is as well as cutting edge as you can get. And there's no limit on which telescopes can see what. Everybody can see something. So I think that's important. In terms of space technology, so the meeting in Stellenbosch, actually, the IAA meeting is actually the combination of two United Nations committees. The one is got to do with early warning, and anybody can join the early warning committee. And then the action committee is same page. Now, I think is the abbreviation pronounced. I think the African Space Agency should join same page as a matter of urgency, because there they will not only meet absolutely fantastic people, but they will also get ideas as to where are the priorities, and that's something tangible that can be done by the African Space Agency with extremely little resources to promote itself and to promote space and the awareness of space and what can happen in Africa. In terms of the actual impact from and the mitigation from asteroids potentially hitting the Earth, I think the COVID pandemic communication effort demonstrates on a global scale what is possible if people put their minds together and get the communication synchronized. I mean, one can have many views about the message, but let's just talk about, I'm just referring to the fact that everybody was synchronized in a way that I didn't understand. I didn't understand how it is possible at a global scale to get the same message packaged in exactly the same way in such short a period of time. That's a demonstration of the kind of early warning and mitigation network, communication network that we need for something like an asteroid hitting the Earth. So it does exist. For me, what happened in 2020 is an example of it does exist. It is possible. We can get together and mitigate against a big threat like that. What it means for Africa is that I think the gaps that were pointed out in terms of emergency response, people want to practice as often as possible, so that the reaction becomes second nature, a stored memory. And I think response to asteroid disasters is maybe not a bad topic for that. It is this simulation that we just saw is such a vivid implication of what can go wrong, and it's not only asteroids; it's tsunamis. It is global warming outcomes. There's so many droughts. I mean, there's so many things that we need to be more aware of, and I think Africa can benefit from that as well on the third leg of the Planetary Defence Conference: astronomy, space technology, and then also the response, the disaster mitigation and response pillar.
Okay, thanks very much. I know we've gone slightly over time, so I think maybe we'll have to stop at this point. I really want to thank all the speakers, Yusuf, Sias, Naomi, David. It's been a very broad topic, and in fact, one of the thoughts that came to mind is that maybe as a follow-up on this discussion, maybe there should be some sort of, I don't know, maybe like a policy brief or something out there for those policymakers and the public. I think it's a very interesting topic. I know some people were a bit scared. This science, astrophysics, so how are we going to understand this? But I'm happy that you all brought it down to ground level, and we all see where the roles that we all can play in the whole scenario. And then finally, I'm also hoping that EFAS, as I know Yusuf and Naomi, you're strongly involved in this, that you kind of lead the platform or the discussion around planetary defense from an African perspective, so that we don't always have to wait for the IAA, we don't have to always wait for an international organization to do that. So we should continue the discussion that has been stirred up, so to say, right now. So thanks, everyone. And I think we all look, I believe that we are now inspired to kind of keep in touch with what's going on around asteroids awareness and to find out more. Just while we were having this discussion, I did a Google search and I just found out that I think in the US, Senator Kelly and Corin, they introduced a bill to recognize June 30 as the National Asteroid Day in the US. I just saw that just while we're having these discussions. I think it's quite interesting what's going on around the world. So thanks again, and I look forward to seeing all of us again, maybe some other, either in person or in another activity. Have a great rest of the day. Bye.
Thank you, Atem.
Thank you.
Thank you for
Thank you. Bye-bye.
Bye, everyone.
Bye.
Bye.
Bye, Yusuf. Bye, Sias. Bye, David.
Bye, Yusuf.
Everyone.